Good morning. Good Monday morning. Listen, this lesson is going to be pretty okay, I think. This part right here I like this a lot actually, because it's something that you're kind of familiar with. So again, it's a bunch of definitions and key concepts, I guess. This is also in that packet I gave you that is separate. So here we go. So the addition property of equality means that if you add the something to both sides, if A and B were equal to each other and you add a C item, then they would still be equal to each other. So for example, if A and B were both 2 because they're equal to each other and you add 1 to both sides, they're still both equal. So this is when you're doing inverse operations and you're adding to both sides. Subtraction, same thing. If my A and B are the same, and you're subtracting the same thing from both sides, almost like your inverse operation, it's called the subtraction property. They are still equal. Multiplication. This is why inverse operations work. So if A and B were the same, and you're multiplying by a value, they are still equal. Division, the same thing. So 2, if we divide these both by 1, it is still equal. So these are easy to remember because you're adding. If you add, if you subtract, if you multiply or divide. These are a little bit different. This one is called reflexive. It's when they are the same. So whether it's A equals A or angle A equals angle A or anything like that, that is called the reflexive property. And we use that name of that property to prove what we're doing. Symmetrical. So if I drew a line here, I could say that this side of the equation and this side of the equation are the same. So that would be like A plus B is equal to B plus A. Something similar to that where it's symmetrical. The transitive property is where you have these two numbers that are equal to each other, and B is also equal to C, so C must also equal 2. Therefore, we can say that A is equal to 2. I think I said this better earlier. Where is my other set of notes? How did I say that? I think I said transfer. Yeah. It's transferring that idea to the other. This one, substitution, we'll use this a lot. So you will be replacing other things by something else in any equation or expression. We use this one often. I'll get to an example of that down here. And of course, you know the distributive property. That one's easy. So let's see what this is going to look like for you. So here we have if ST is equal to WX and WX equals something else, then ST is equal to YZ. Which one is that? Hopefully you said the transitive property. A equals itself. A equals itself. So that would be the reflexive because it's the same. Go ahead and write that out. So what we're doing when we go to prove things, we need to use these properties to state how did we get from this step to the next step to the next step. This next one is, I'll let you look at this and think about this first. So to get from here to here, we had to subtract 9. Your hint, subtraction property. Okay, this one. So AB is equal to 10, and then AB equals to CD. Therefore, CD equals 10. Now, you might want to think that's transitive. But this is where you're substituting in. Substitution. And I'm not for sure if Alex calls this something else, so I'll have to kind of go back to that when we look on Alex, but it's the same idea. All right, on this next page, it's blank, and I really don't want this to be blank. So you guys are babies, so I am going to write a few of these out. Okay. First of all, anytime you have a given, that is the first thing you write. So we're going to write that here. 10a minus 1 equals 4a plus 5. And the reason why we wrote this is because it was given. So you're almost like scientists there. How do we prove that a equals 1? So that's where we need to get. So the proof always goes down here. All right, so basically we're going to solve this. So if you needed to solve this, we would subtract 4a from both sides. So 10a minus 1 minus 4a is equal to 4a plus 5 minus 4a. Okay, I know writing it out like this is not, we're used to writing it downwards in a V method, but we're going to start writing them kind of like this here. So we subtract the 4a, it's the smallest, and so when I do so, that would be the subtraction. We subtracted, so that's the subtraction property. So as you can see, we'll clean this up. When we clean it up, this becomes 6a minus 1 equals 5. This is just called simplify. So maybe we need to add that somewhere. Okay, so keep solving. We're going to add 1 to both sides, plus 1. Plus 1, or you could automatically say 6a is equal to, well, we'll get to that because that's called simplifying. So this is addition. This time we add addition property. A lot of times they don't have the simplify, they just go straight to it. So they would go from this equation to this equation, and you would just call it the subtraction. So we've kind of added this little simplify thing, and if it helps you, you can have as many steps as you need, just FYI. So we're going to go ahead and simplify this again. So we have 6a is equal to 6, so that we just simplified it. And now we're going to divide both sides by 6. So this is the division property. And then we got to here because we simplified. So that was pretty easy. I think, like I said, you'll like this. Let's go down here. So again, anytime you have your given, which is right here, if a, b, measure of b, so it's got a little m, it means the measure of b is equal to 2 times the measure of c, and the measure of c is 45, then the measure of a must be 90. So we could draw a picture of this. These are angles. So we're going to prove that a is 90. So we're going to prove that a is 90. So we have the measure, so this whole thing is A, angle A. I hate to do this because then, and then this is angle B, and this is angle C. So it says that C is 45. Okay, see how we can get with this one. So let's put our given here. So angle A is congruent to angle B. The measure of angle B is equal to the 2 times the measure of angle C. Why does this look wrong? But I'm going to keep going. So the measure of angle C equals 45. This is given. So measure of angle A is equal to measure of angle B, right? Measure of angle A is equal to the measure of angle B by the definition of congruent angles. Oh, I see what I did here. So angle B is like this. I think they're all separate. Isn't that hard to read? So this is angle A. Angle C is 45. I knew this picture didn't look right. Angle C is 45. Angle B is twice 45, which is 90. Okay, gotcha. All right. So they said that we can say that since these two are congruent, we can say that they are equal to each other. And that's that definition of congruent angles. And we talked about the definition of congruent being you change from, and it can go back and forth, that to that. Okay? And then since the measure of angle A would also be 2 times the measure of angle C, so we took this and made it over here, that would be that transitive property. We transferred. Transitive property. Then, since we knew that measure of angle C is 45, and we stuck 45 in here, that's called substitution. Therefore, the measure of angle A is equal to 90. And that is because we simplified the step above. Hope that makes sense to you. The assignment is a Google form, and I think they're fantastic. I'll give you multiple tries. It's good practice. I've also started a flashcard. I'm going to go ahead and put online with all of these properties, all these theorems and postulates and definitions. So hopefully that'll help too. All right. Those of you who want to stop and start the assignment, please do so. Otherwise, I'm going to continue. Situated, here we go. Okay, so this time we're talking about segment relations. So here's your first postulate. The points on any line or line segment can be put into one-to-one correspondent with real numbers, basically meaning that you can measure it. Given any 2 points, A and B on a line, if A corresponds with 0, then B corresponds to a positive real number. Next one. Segment addition, and we've already done this before. So if A, B, and C are collinear, so they make this straight line here, then point B is between somewhere. It doesn't say midpoint. It's just between A and C. that means that AB plus BC is going to equal this whole thing. And that's what you did last chapter. Okay, here's the transitive of congruence. So if AB is congruent to CD and CD is congruent to EF, then you're transferring, or the transitive property is saying that this is now congruent to that. It's a transfer. Here it says a paragraph proof, since AB is congruent to here, this is congruent to here. You could change this to equal signs by that definition of congruent segments, and then back and forth. Okay. Property of segment congruence. This is the reflexive. It's no different, but these are, instead of points or anything else, they are segments, line segments, so that would be the same thing. That reflexive, it's the same as each other. Symmetrical, again, if I put a line here, this side is symmetrical to this side, it's reversed. The transitive, we just kind of talked about this, but we're talking about, do they have the same thing? Yep, transitive property of congruence, that's up here. We've already talked about that. So that's another bigger visual for that one. Okay. All right, so let's try this proof. Luckily, they have this nice picture for us. The first thing that they give us, given, is this. So we always say that's given. Always makes me feel good to get that done first. And then here's a picture. So let's understand this picture. They're saying that AB and CD are congruent. So let's just mark that. Therefore, that AC, here to here, and BD must also be congruent. I see some transfer of stuff. So what is the definition of congruent segments? We need to change this, instead of a congruence, to an equal sign. So let's change this to AB is equal to CD. On Alex, you have to put these lines on here. Sometimes it can be annoying, but don't forget these little things on Alex once you start getting on there. And then when you see something that says BC is equal to BC, what do you know about that? If you said reflexive, you are right. Now this, we are saying that A plus B, AB, plus B plus C equals AC. And that's that segment addition postulate. So if we substitute, what would that look like? Instead of saying AB, we would substitute this term CD. So CD plus BC is equal to AC. It's kind of a reach. Now, since we said this, we change this to BD. So we're saying CD plus BC is equal to BD. So segment addition postulate. So you really have to always go back and look at your picture. Then we said AC is equal to BD because we just transferred that information to each other. And then to make this back into a congruence, it would be the definition of congruent segments. Whew. You did it. Sometimes these are super annoying, but so far so good. Just take baby steps. So here's another example. And we've got a picture down here Hopefully yours does too. Anyway, it says, let me move up here so you can actually see. Jamie is designing a badge for her club. The length of the top of the badge is equal to the length of the left side. So the length of the top, the badge is equal to the length of the left side. I'm on the right, left side. So if this is a certain amount, this is a certain amount. So these would be the same. The top edge of the badge is congruent to the right side. Well, and the right edge of the badge is congruent to the bottom. So we know we have a square. Prove that the bottom edge of the badge is congruent to the left edge of the badge. Okay, so we've got all of this stuff that was given. We've got this nice picture. If the picture wasn't there, I would make you draw a picture. So you've got all of this, and it is given. Next, we have a WY is congruent to YZ. The segments. So definition of congruent segments. Then we have YZ is congruent with YX. So we replaced, these two go together, and we replaced this with this. So what we're saying is up here we transferred this information. So YZ is equal to this guy here. That would be the transfer or the transitive. I know, isn't this lovely? Then instead of having YZ, we change it to YW, and that would be substitution. And then we go back to here. We just kind of reversed it. So when we reversed it, that would be symmetric. Yowza. Okay. So let's see. You almost wanted to say substitution here, but you have to go back up here, and we just replaced this. So we replaced that YZ from this statement up here. Okay. Do we have more? We do not. You are done with this lesson. Again, it's a Google form with this practice. I think I'm going to let you do unlimited tries or several tries on that Google form so you can learn. And of course, at any time, ask me questions. All right.